3, it says, a psychology experiment sometimes involves testing the ability of rats to navigate mazes. The mazes are classified according to difficulty, as measured by the mean length of time it takes rats to find the food at the end. One researcher needs a maze that will take rats an average of about 1 minute to solve. So it's going to take about 1 minute to solve. He tests one maze on 21 rats and finds the sample mean to be 52.21 seconds with a sample standard deviation of 13.56 seconds. From previous data, it is not unreasonable to think the maze times are normally distributed. He finds the 95% confidence interval to be this value right here. Would you support the researcher's claim that the mean maze time length is at least 1 minute? Explain your reasoning. So we're interested in knowing if this mean maze time length is at least 1 minute. Let's do a couple of things and verify that this is the actual interval that we're getting with this particular data. So we can do it. Let's actually go both ways and do it by hand and then verify with the calculator. So I know that the X bar here is equal to 52.21 seconds. S of X is equal to 13.56 and N is equal to 21. I need to find a T star at 20 degrees of freedom this time. And to do that, I'm going to do inverse T. They want it to be 90%. So remember, 90% means you have 90% on the inside. So it means you have 5% over here and 5% to the other side. I'm going to calculate up to this value right here. So this would be inverse T, 0.95. And again, degrees of freedom are 20. And so when I do this in a calculator, first find T star. So I'm going to do second bars, inverse T, 0.95, degrees of freedom are 20. And so my T star at 20 degrees of freedom is equal to 1.72, and we'll say 5. So if I want to find the interval by hand, I do X bar, 52.21, plus or minus the T star, which is 1.725, times S of X, 13.56, divided by the square root of N, which is 21. And again, I can calculate the margin of error first, which is this part right here. That is E. So I'm going to do 1.725 times 13.56 divided by the square root of 21. And I get an E equal to 5.104. So I'm going to do 52.21 minus 5.104. The lower bound we see is 47.1. And the upper bound, 52.21 plus 5.104. The upper bound is 57.3, which is what the problem stated it was. Right here. So that's by hand. Now, if I do it with the calculator, remember I would go stat, test, T interval. And again, plugging in the information that's given to me, X bar, 52.21, S of X, 13.56, N, 21. And this I'm doing 90% confidence, so it'll be 0.90. And look at the values you get, 47.1 to 57.3. So those values are verified by hand through the calculator. Now, here's what I want to know. Here's the ultimate part of this problem. The question asks me, would you support the researchers' claim that the mean maze length time is at least 1 minute? And remember what a confidence interval is. A confidence interval is a plausible values for some population value. Well, we're worried about it being at least 1 minute. These are based off seconds. So right now this interval goes from 47 seconds to about 57 seconds. Does that justify the claim of being at least 1 minute? Well, the answer there is no. Why not? This entire interval is less than 60 seconds. If it were at least 1 minute, you would need to see numbers bigger than 60 seconds inside the interval. So because no, the entire interval is less than 1 minute. Now, could you make the same claim then at, for instance, 95% confidence? Well, what would 95% confidence do to an interval that is 90%? Would it make it bigger? Would it make it wider or narrower? Because I'm becoming more confident, the interval has to get bigger. So watch what happens at 90% at 95% confidence. I'm going to change that 0.9 to 0.95. Could you make the claim at 95% that it's at least 1 minute? Still, no. Why? Because the lower bound and upper bound, they're all under 60 seconds. Well, what about at 99% when it makes it even wider? Make it 99%. Could you make that claim at 99% confidence? Yes. Why? Because the upper bound encompasses the number 60, and 60 will sit inside the interval. So it's also greater than 60, which means that it is plausible to believe that at 99% confidence, that mean Maisling time would be at least 1 minute. But anything else in that is going to be less than it. So what this does, this answers, you can start to answer certain questions based off the interval itself. And what you're doing is you're looking for values to either fall inside of the interval or outside of the interval. Here, 60 seconds will fall outside of the 90%